So Quine-McCluskey method determines determination of prime implicants. The function must be given as a sum of mean terms. So when you solve the problems in exam, usually they give the mean terms, okay, for solving the Quine-McCluskey method. So how do they represent the mean terms? That is sum of mean terms they will be giving. So for example, f is equal to a, b, c, d is equal to summation of mean terms 0, 1, 2, 5, 6, 7, 8, 10, like this. So expressions they will be giving, okay, sum of mean term expressions. So using that, keeping that as a first step, you are going to solve the next problem. So if you have sum of mean terms, you can represent that sum of mean terms in the truth table also. So here we have taken directly the truth table. We have not shown a function. Okay, in your textbook you have a problem there where they have written f is equal to a, b, c, d with the summation of mean terms. Okay, certain expression they have given. If they have not given, they may give you directly the truth table itself. Okay. In the first part of the Quine-McCluskey method, all of the prime implicants of the function are systematically formed by combining the mean terms. So here you can see that there are certain mean terms here. So it is a 4 variable truth table with the output variables they have written here, that is y with y. Okay, so mean terms here mean term 1 you have 0, it starts with 0, mean term 0, mean term 1, mean term 2, mean term 3, so it goes on up to mean term 15. Okay, so here you don't have anything, that is all zeros here. So expression includes only these mean terms, that is with ones. Okay, because they are writing the sum of mean terms. So let us move on to the first stage of your Quine-McCluskey method. So in order to find all of the prime implicants, all possible pairs of mean terms should be compared and combined whenever possible. So to reduce the required number of comparisons, put mean terms in different groups depending on how many input variable combinations you have. So what it means is, here if you see, you are going to group in group 0, group 1, group 2, group 3, group 4, like this. Okay, so how we have grouped these terms here? You are going to see how many number of ones you have. Here you have number of ones are 0. Okay, how many you have in this group? Number of ones are 1. Okay, here you have 2 ones everywhere. See here, 1, 2. 1, 2. So 2 ones you have. Next you have 3 ones. Here in this group, in this group you have 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is with ones with so three ones you have. Last group has 4 ones. So like this you have to group it. Okay, so your mean term may be starting from 0, 1, 2, 3, 4, 5, 6, some numbers, but you have to group it according to the number of ones. So see here, groups depends on how many ones input variable combinations you have. Okay, so that is what you have to see here, the first stage. So we have grouped mean term 0 here with the group zeros, that is number of ones are 0 here. And the next group, that is 1 and 2 mean term, this is showing the mean terms. Okay, 1 and 2 has got this. So only mean terms you have to consider here, rest you have to leave. Only mean terms we have grouped in this manner. That is, so if you have solved this stage 1, you will be getting 3 marks out of 10 marks. Okay. In stage 2, we try to combine first and second group of stage 1. First and second group of stage 1 on member to member basis. So that is in stage 2 we are going to do this. We have to combine now, start combining. The rule is to see if only one binary digit is differing 2 members and we mark that position by dash. This means corresponding variable is not required to represent these members. Thus, 0 of the first group combines with 1 of the second group to form 0, 1 in second stage and can be represented by A bar, B bar, C bar. or you can represent it as 0 0 dash. Okay. Okay, so here which formula they have applied here? That is your same formula, whatever I have said earlier. Xy plus xy bar, is it? Xy bar is equal to x. So same formula they have applied here to get to combine. That means here you say y bar as 0. Okay, here you have 1. Y as 1 I represent. Okay, so x, think that x is also has taken value 0. Okay, here also 0. So when you start combining this value 0 1 plus 0 0, you get answer as 0 itself. Okay, because this 1 and this will be cancelled and you get only 0. Okay, so that is what they have to represent here. So that is that thing, whatever you don't show here, this term has one has changed to 0, that term will be mentioned as dash. Okay, that is what we are going to solve in Quine-McCluskey method. Everything whatever you have written in this manner, that is 1 changes to 0 or 0 changes to 1, such things will be represented with dash when you try to combine, only that case. Okay, thus in the first group that combines, so think that 0 of the first group combines with 1 of the second group to form 0 1 0 comma 1. Okay, in the second stage it can be represented with 0 0 0 dash. Dash means some variable was changed from 0 to 1. Okay, so that case we have written this one. So proceed in the same manner to find the rest of the combinations in successive groups of stage 1 and table them as in the figure. So all the members of the particular stage which finds itself at least one combination of the next stage are ticked or check mark. Okay, this has to be followed for the stage 1 terms as well as the terms of the other stages. So the checking marks, or you write something when you are going to combine in this manner 0 comma 1. You are okay, when you start combining, you start checking the previous stage. Okay, that will see like this, you'll be go on checking that check marks. Okay, that means if suppose the group 0 is combined with the mean term 1. Okay, so that time you write 0 comma 1. So that time the mean term 0 and 1 has to be checked. Okay, like this we do. Two terms can be combined if they differ in exactly one variable. Comparison of the terms in non-adjacent groups is unnecessary because such terms will always differ in at least two variables and cannot be combined using xy plus xy bar is equal to x. So similarly, the comparison of terms within the group is unnecessary because two terms with the same number of ones must differ in at least two variables. So thus only terms in the adjacent groups must be compared. Each time a term is combined with another term, it is checked off. So this is the main thing you have to do. Unless you check off, you cannot get the prime implicants later. Okay, so that's why whenever you try to combine any of the groups, you have to check. You have to make a check mark. Okay, or just make a tick there. Okay, so only adjacent groups are being combined. It must be compared first. Okay, so you think that mean term 0 has to be compared with mean term 1 first. Okay, not with the last term or 15th term. Okay, one by one you have to go on checking that. So 0 with 1, then 0 with 2, 0 with 8, 0 with maybe 10, like this. So one by one, the nearest things we have to start combining, and later we can move on to the last terms. A term may be used more than once because x plus y, x is equal to x itself. Okay, even though two terms have already been combined with other terms, they must be compared and combined if possible. So you have to try to combine all the adjacent groups, and if you have already combined, still you have to check once more. And actually at the stage of maybe in the second stage or third stage, some redundant terms will be getting cancelled. So but the so that redundant terms has to be eliminated later. Okay, so you say 0 comma 8 comma 1 comma 9. Okay, it may be redundant. Okay, think that it is same as, so you write 0 comma 8 1 comma 1 comma 9, it's same as writing 0 comma 1 comma 8 comma 9. So 1 is redundant, is it? Or you say 0 comma 1, you write, okay, 0 comma 1 is same as 1 comma 2, 1 comma 0. So that one term will be redundant term, so that one term you have to cancel, and another you have to keep as it is, okay, in the problems. So let us start the problem. So what you do here is the stage 1. Stage 1 is already we have written in the earlier slides. Same we have written here. Let us move on to the next stage, that is stage 2. So what the theory portion we have said in slide 2. So that some rules whatever you have said there will be repeated here in the terms of problems. Okay, let us see how the problem goes. So here what you have to do is, first you have to see that is mean term 0. Okay, this is group 0, is it? Group 0. Next you have group 1, or I mark it here. This is, or you say here, this is group 0, group 1, this is group 2, this is group 3, and you have at last group 4. So there are 0 to 4, that means 5 groups you have. Huh? So let me see how you can solve the problem. You are going to have the mean term, that is 0, with 0 number of ones, is it? So you have to, what you have to do in stage 2 is, you have to start combining this term with the next adjacent terms. Okay, so 0 has to be first add, it has to try to combine with 1, whether it is possible. Also that time you have to see how many number of matching terms you have. Okay, so here this matches with this terms, is it? So you can combine now. Only one term is going to be changed from 0 to 1. So that's why I tried it as 0 and 0 comma 1, and 0 0 0 and 0 0 0. So that's what we have written 0 0 0 here. And the term which we have changed, it is 0 has changed from 0 to 1. That term I have written as dash. Okay, that is the first step. So after seeing writing these, okay, if you want to solve the next problem, what you are going to write? Try to combine 0 with the next term, 0 with 2 now. So again you see how many terms are matching with this. Okay, here 3 zeros are matching with 3 zeros of mean term 2. So only one variable changes from 0 to 1. That term we are writing it as dash. So that is written as 0 comma 2. Okay, so as you go on combining, you have to check mark the stage 1. Okay, so try to see that can 0 be combined with the other terms. Okay, it cannot be combined here in later cases. Why? Because your terms, 3 terms has to match actually. That won't match with the other terms here. So if you are seeing here only two zeros you have here, 1 zeros. Okay, that won't match with the mean term 0 here. So that's why leave that case and move on to next step. So what you will be doing in the next step? Okay, so whatever you have checked, all that has to be remain as it is. This is done, this is done. So that means 0 combined with 1, 0 is combined with 2, that all we have checked or ticked already. So next thing is, try to combine the next, see that you have to move on to next step, that is grouping of only 1. So here you again you have only zeros. Here in this group you have only ones, that is single one. Okay, here in this group you have two ones. So that is what we have done. Here you have three ones. So same way. So here let me see, one be combined with 2? One be combined with 2? No, you cannot combine. See here 0 0 is matching, but here this term is different, is it? So that's why it won't match. So you go for the next term, that is 0 matching with 3. 0 matches with 3. Sorry, 1 matches with 3. So what you have done, try to see that 1 matching with 3, whether it is matching. So your terms 0 0 is matching with this, 1 is also matching with this one. So that's why, and 0 changes to 1, so that's what we have written here. So you are going to combine 1 and 3, check mark this third mean term, and we have written here, what is that, 1 comma 3 is 0 0 dash 1. So similarly you try to combine with the other next adjacent terms. 1 with 10, is it possible? No. 1 with 12, is it possible? No. Try 1 with 11, not possible. 1 with 13, not possible. 1 with 14, not possible. 1 with 15, not possible. So leave that. Okay. Next step, what you have to do is, you have to move on to the next term, that is mean term. You have 2, mean term 2. So move on to that mean term. So mean term 2, can it be combined with 3? Yes, you can combine. Why? Because this 0 0 1 matches with 0 0 1, and only one term changes from 0 to 1. So that you can write it as dash. So that is what we'll be writing as here we have written 2 3, that is 2 3 is 0 0 1 dash. Okay, so that is matching. So 2 3 is come. So already have checked it, so no need of checking it again. Already have checked. Check mark is done. So that's next step is try to combine, whether you can combine 2 with the 10, whether it's matching. See, just to see that whether it is matching or not. If you see here, 0 1 0 matches with 0 1 0 of this. Only one term changes from 0 to 1, so that you can write it as dash. Dash 0 1 0. So here dash 0 1 0 is 2 comma 10. So that's what 2 comma 10 is combined, and you write check mark. Next step is what you have to do. Try to see that 2 can be combined with 12, 2 can be combined with 11, 13, 14, 15. No, not possible. So leave that and go for the next step, that is combine. Next step is to combine. Have to see. Next term is 3. Mean term 3. Mean term 3. So this mean term we are going to consider. Mean term 3. So whether this can be combined with the other terms, you have to see. Mean term 3 cannot be combined with 10, 12, 11. It can be combined. Why? Because 0 0 1 matches with 0 0 1 1 matches with 0 1 1 of this, and it can be written as dash 0 1 1 3 comma 11 is being matched. So that is what you will be marking in this manner. Okay. And next step is, can 3 be combined with other terms? No, not possible. So go for the next step, that is mean term is being selected is 10. Is it? 10th mean term is selected. So what is the term here? Can 10 be combined with 12? No, not possible. So next, which term you have? 10 combined with 11. 10 combined with 11. Can it be done? Yes, you can do that. How? Let's see that. See here, 10th term and 11th term is being combined. 101 is combined with 101, and 0 changes to 1. So that's what we write it as 101 dash. Done. Okay. So 10 is combined with 11, 14, 13. 13 is not possible. 10 can be combined with 13, not possible. 10 can be combined with the 14. Okay, that's what you have to see here. It can be combined, can be done. So that's why just take which are the terms which you are going to combine here. 1 0, this one here, 1 1 0, and so that is what 0 changes to 1, that can be written as dash. Okay, so 12 and 13, sorry, 12 and 13 is sorry, not 12 and 13, 10 and 14, 10 and 14 is being combined, so we mark like this. Okay, next term is 12, 12th term. Can you combine with 13? Sorry, can be combined with 11? No, not possible. So try to combine 12th mean term with the next term, that is 13. Try to combine 12 with 13. Can you do that? 110 is matching with 110 of this. So 0 changes to 1, that can be written as dash. So that is what 12 and 13 is being check marked, and also we have written 12 and 11, 13 is written here. That is 110 dash. Next term is 12 and 4. Try to see that 12 and 14 can be combined. Just to check that. So which are the terms that is being matched? See that. Okay. So here 0 matches with 0 of this. 1 matches of 12th term matches with 14th term of this. 0 changes to 1, so that can be written as 11 dash 0. So we are already check mark 12 and 14, so no need of doing that step. So this is particular step. So 12 can be combined with 15, not possible, so leave that. Next term what you have to check is 11. Can 11 be combined with 13? Not possible. 14 with 14, 11 can be combined with 14, not possible. 11 can be combined with 15. It's you have to check it, and it's matching, is it? So it's matching. So all three ones you have here. So 0 changes to 1, that we can write it as dash. Okay, 1 dash 1. So that you have to check mark. So all stage 1, all mean terms are checked. Okay, what's the term here? We are going to write it 11. That is 11 combined with the 15. Is it 1 dash 1 1? And next thing is 13. You have tried. 13 can be combined with the other terms. Just see that. So later you will be writing it as 13 and 15 combination, and also 14 and 11, 15 combinations is also possible. So this is the stage 2. We have solved the problem in stage 2. You stop the procedure here. Next step you have stage 3 also you have. So let us move on to that. In stage 3 we combine members of different groups of stage 2 in a similar way. Whatever earlier we have done, same way you are going to follow. Now it will have 2 dash elements in each combination. This means each combination requires 2 literals to represent it. So that means you will be having double dashes in the next stage. Okay, till now we have only single dash. So next stage you will have double dash. So there are 3 other groups in stage 3. So for example, it's represented as B bar C, as you are going to represent as 10, 14, 11, 15, and AC as 12, 13, 4, sorry, 12, 13, 14, 15 by AB. Okay, so these are represented later in the later stages. Note that 0, 2, 1, 3 and this 10, 11, 14, 15 and 12, 14, 13, 15 get represented by A bar B AC plus AC and AB respectively, and do not give any new mean term. So later in the later stages you are going to represent all these combinations by terms actually. Okay, so let us see how we are going to do that the next stage. So till now we have solved the problems, that is we have solved stage 1, stage 2, up to here it is done, but marking of stage 2 is not done until here. So let us move on to the third stage now. Third stage, so that is how you can do that. So same procedure whatever we have done we have to follow now. Okay, you have to start combining 0 1 with the next adjacent term, that is possible. 0 2 with 0 2 not possible. Okay, so it's only two terms are matching, other two is not matching, so leave that step. Try to combine 0 2 with 0 1 with the next term 1 3. Can you do that? Not possible. So try to go on next step, that is 0 1 with 2 comma 3. Can it be done? Okay, you have to see that. So now you have to have double dashes. So 0 changes to 1, that is matching, is it? And 1 dash you have, that is also matching. And 0 0 matches with 0 0 of here. So that's why you can combine now 0 1 and 2 3. Okay, 0 1 2 3. So that's what we have written here, 0 0 dash dash. Okay, in the next step try to see that whether you can combine with 2 10 3 11 0 with 10 11. Can it be done? Not possible. So go on doing this procedure until you see whether you can combine it with 14 11. Not possible. Okay, so leave that. Okay, so until here we have checked only two terms, that is 0 1 with 2 3. So this is complete. Okay, so now next term is 0 2. Again you have to see whether you can combine it with the very next adjacent term. So 0 0 is matching with 0 0 of this 0 1, that you can represent with dash. So this dash also matching with this uh, 1 3 dash. So that's why write it as 0 0 dash dash. Okay, done. So which two terms are getting checked now? You have to check mark 0 2 with 1 3. So that's done. Okay, that's so. So now we have to check on checking 0 2 with other lower terms also here. Lower terms also you have to see whether it can be combined. 0 2 can be combined with the other lower terms. Not possible. So leave that. And you can see that this 0 0 whatever you have written here. Okay, it's all group of zeros. Okay, no single term of 1 you have in this group 0. See? So next group has single 1. Other next group has double 1. Is it? Okay. So let us try to see the next group possible. 0 2 can be combined with 2 3, not possible. 0 2 can be combined with the 2 10, not possible. So try to see that, not possible. So leave that step. Okay, now next term what you have to check is 1 3. Can 1 3 be combined with the other terms? Not possible. So leave it. Okay. So go on doing this procedure as we have said earlier. So can 2 3 can be combined with other term adjacent terms? It's not matching with any other terms, so leave the term. And the next term we have to come see, that is 2 10. 2 10 can be combined with other term. Yes, it can be combined with the very adjacent term, it's 3 11. So that's why 0 1 0 matches with 0 1 of this, and this particular thing, that is 0 changes to 1, can be written as dash. So that's why we mark 2 10 and 3 11. Okay, so that's what we have written here, 2 10 311 can be written as dash 0 1 dash. Can 210 can be combined with other next adjacent terms? 10 11 10 14 you have 12 13, not possible, so leave this procedure and go on to the next term, that is 311. 311 can be combined with others, not possible, so leave that. Can 311 be combined with the sorry 1011 can be combined with the next term? Just to see that. So 10 11 can be combined with 14 15. Yes, possible. So which term is getting changed? That is 0 1, 0 changes to 1. There you can mention dash 1 1 dash, sorry 1 dash 1 dash. So that is what we have written. 10 11 14 11 can be 14 15 can be combined. Okay, so whenever you combine 10 11 you have to check mark. Okay, because later you have to find the prime implicants, that's why we are going to check mark like this. So in the similar manner we have done other terms also in the same manner. It's 10 14 11 15 12 13 14 15 12 14 13 15, so like this. So as you have done the combinations, we have check marked certain variables like this. 12 13 14 15 is combined, 12 14 13 15 is also combined. So all the terms in the stage 2 is being combined, and we have written for the next stage 3. Okay, stage 3 we have got. Selection of prime implicants. So once we are able to determine the prime implicants that covers all the terms of the truth table, we try to select essential prime implicants and remove the redundancy or duplication among them. So to find the minimum expression, we construct the prime implicant table in the very next step, in which there is a row for each prime implicant and a column for each mean term that must be covered. So note that don't care values are not included here. So we place check marks by tick or X marks to indicate the mean terms covered by the each prime implicant. So next stage what we have to do is we have to select some of the prime implicants. But how to select this? So which are not in the stage 1, stage 2, stage 3. If any term is not being check mark, so that term we call it as a prime implicant. So that you have to select in the table, only those. Okay, so which are not being check marked. Okay, that will be the prime implicants. Selection of prime implicants from this table is done in the following manner. If the mean term is covered by only one prime implicant, then that prime implicant is called an essential prime implicant and must be included in the minimum sum of products. Okay. So this is for the next procedure. You have a separate table for this to get the minimum sum of products. So up to here, whatever you have done is stage 1, stage 2, stage 3. Okay, it can be followed for the next stages also, but usually in the exam you get up to stage 3 only. Okay, so here in this particular problem, what you have to do, the next step is you have to form a different table where you are going to write the prime implicants. Okay, prime implicants are selected from the previous step. Okay, so which terms you have not unchecked. After combining so many combinations, some terms will be left out without combining. So that terms is considered as a prime implicant that you have to choose for the next step. Okay, so essential prime implicants are easy to find using prime implicant chart. If a given column contains only one check mark, then the corresponding row is an essential prime implicant. And circle the check or dash mark. Okay, each time a prime implicant is selected for inclusion in the minimum sum, the corresponding row should be crossed out. Okay, after doing this, the columns which correspond to all the mean terms covered by that prime implicant should also be crossed out. Okay, the essential prime implicants and the corresponding rows and columns are also crossed out. So this cross marks has to be done in the next step. Okay, so one at the left hand side only prime implicants you will be having. That means in terms of if you write in terms of rows and columns, the columns will include all the mean terms, the rows will include all the prime implicants. Okay, that you have to remember first. Okay, a minimum set of prime implicants must now be chosen to cover the remaining columns. So find the minimum set of rows that cover the remaining columns, or find the minimum number of prime implicants that covers all the mean terms. So one of them is included in the list of prime implicants, making if there are three. Okay, so there are possibility of two expressions. So here in this case, so y is equal to a bar b bar plus b bar c plus ab, or y is equal to a bar b bar plus ac plus ab. So in this particular problem, there are possible of two expressions you are getting at last. Let us see how to get that. So in the previous stage, we have done stage 1, stage 2, stage 3. So here in the next step, what we have to do is we have to find the different combinations now. So try to see that in stage 3 also, try to combine the 0, 1, 2, 3 with the next term. Whether it is possible to combine, you just see. It's not possible. So try to see that whether it can be combined with this term. That is not you cannot do this particular thing also. So now the next stage will be usually having 3 dashes. So that thing you have to see. Okay, so whether it is possible to combine, just to see that, go on trying with the different terms. It's not possible. So any combination is not possible here. So leave it and try to go for checking the next term, that is 0, 2, 1, 3. So it's same as previous, right? 0, 2, 1, 3 and 0, 1, 2, 3 is same, almost same. Still, you check it whether it can combine with this term, whether it can be combined not. Okay, whether it can be combined 0, 2, 1, 3 is can be combined with 10, 11, 14, 15, not possible. 0, 0, 2, 1, 3 with the 1, 1 dash dash is not possible. So it's not possible to combine. So leave it. Okay, so again, so in the similar manner, try to see that whether 2, 10, 11 can be combined with the other terms adjacent to it. Not possible. Again, 10, 11, 14, 15 can be combined with the adjacent terms. Nope. You leave this. Okay, so any check marks you have here? No, nothing is being combined, so no check marks. So now all these are called all these are taken for the next step. Okay, all these terms whatever you have here are taken for the next step. So here you can see that there are redundant terms. 0, 1, 2, 3 and 2, 0, 2, 1, 3 is same. Redundant term. Okay, both are same. Okay, all terms are present. So writing 0, 1, 2, 3 is same as writing 0, 2, 1, 3. So that's why we take only one single term, that is 0, 1, 2, 3. Anything you can take. We have chosen 0, 1, 2, 3. So that's what written here. So when you say 0, 1, 2, 3, it is of A variable 0, B variable 0, C and D is dash dash. Is it? So what is that term now? It is here A has taken 0, B variable has taken 0. So that means what? It is A bar, B bar. Then rest you have to leave. So that's what we have filled here in the next stage. That is A bar, B bar. Okay, similarly, the next term, that is 2, 10, 3, 11. 2, 10, 3, 11 is, what you can write for this? What is can? That is B bar C. A and D has 0 value. So that is what B bar C. Okay. And next term is 10, 11, 14, 15 is same as writing 10, 11, 11, 15. Okay, so take only one single term, that is 10, 11, 14, 15. Here also we have taken single term. Okay, now B bar C is written here. Now next thing is you have to write this term. Okay, 10, 11, 14, 15. So that's what we have written, that is A takes the value 1, B nothing, C has 1. So that's what we write it as AC. Okay, so next is 12, 12, 13, 14, 15, and 12, 14, 13, 15 is same. So anything you can take. We have written only single term since other is redundant. 12, 13, 15, 15 we take, so that is AB. Okay, so that is what we have written here, AB. So this is needed for the next step, prime implicant chart. So all these are prime implicants. Now you have to find which are the essential prime implicants, because essential prime implicant is finally written in the minimum expression.